Hi, in this video we will be covering section 4.1, multiplication of like bases. In this section it is all about properties of exponents. So multiplication of like bases, b to the m times b to the n, which is the product rule, b to the power m plus n. You are adding the exponents. To give you an example, if we have b cube times b to the power 4, it is b to the power 3 plus 4, which is b to the power 7. You are going to add the exponents, making sure the bases are the same. And this is multiplication. And division of like bases, b to the m over b to the n, which is b to the m minus n. So you are actually subtracting the exponents. So in this case, if I give you an example, it is b to the power 7 over b to the power 4 will be b to the power 7 minus 4, which is equal to b cube. So if you are dividing, then you are going to subtract the exponents. Here also make sure that you have the same base, b. Power rule, it's b to the power m to the power n is b to the m times n. So to give you an example for this, if you have b to the power 4 whole square, which is going to be b to the power 4 times 2, which is b to the power 8. So it is power over a power, so it's kind of superpower. So you're going to multiply the powers 4 times 2, which is 8. The power of a product. So a times b to the power m is a to the power m, b to the power n. So to give you an example, if you have a times b to the power 3, which is a cube times b cube. A power of a quotient, a over b to the power m equal to a over m divided by b over m. So we have a over b to the power 5, so it will be a to the power 5 over b to the power 5. These first set of properties that we discussed are the main properties of exponents, and we have some additional properties of exponents. And the first one is zero property, which is b to the power 0 equal to 1, or anything to the power 0 is 1. So if I take 5 to the power 0, which will be equal to 1. Negative exponent, b to the negative n equal to 1 over b to the n. If you have a negative exponent on the numerator, you can bring it down and write as positive exponent in the denominator, which will be 3 to the negative 2 can be written as 1 over 3 to the positive 2. Then negative exponent with quotient inside the parentheses is a over b to the negative 1, negative n. Then you can flip the numerator and the denominator and write b over a to the positive n, which will become b over n over a to the power n. To give you an example of this one, so 7 over 3 to the power negative 2 will be 3 over 7 to the power positive 2. So we are actually flipping the numerator and the denominator. Then it becomes 3 square over 7 square. So all these properties will be helpful in doing these problems. So let's see some examples. So it's x to the power 10 over x to the power 4. So it looks like x to the power n, it's like quotient. We have the same base. So we are going to apply the quotient rule. So it is going to have, because it looks like a quotient, we have the same base, yes, the x. So it is x to the power 10 minus 4 using the quotient rule. So it's x to the power 6. So which rule are we applying here? The division of like bases. That's what we are doing here. Then let's try one more of this kind. So we have anything to the power 0. Here you have negative 7 x to the power 6 y z cube divided by 21 x cube y z square. So don't let this scare you. Ultimately, you notice it is to the exponent 0, and you know that any number raised to the power 0. So if we have something like some x to the power 0 equal to always 1. Anything to the power 0 is 1, which is one of the properties that we saw, which is known as 0 property. Any base to the power 0 equal to 1. So in order to remember this, if you have something inside the parenthesis and then exponent is 0, that's always going to be 1. So it is equal to 1 in this case. 5 to the negative 1, so it is coming under the negative exponent that you did. So b to the negative n equal to 1 over b to the positive n. So you can write this as 1 over 5 to the negative 1 can become positive 1. But 1 over 5 to the 1, if the exponent is 1, you can write the base by itself. So it's 1 over 5. Now, 1 over 5 to the negative 1, this is going to be, you can move this guy up 5 to the positive 1. So which is just 5 to the 1, which is equal to 5. So if you see anything in the, either the numerator has negative exponent, you can bring it down and make it positive. The denominator has a negative exponent, you can move it up and make it a positive exponent. Now we have negative 6 over 5 to the negative 1. The negative 6 on top stays as negative 6, that doesn't change. And this 5 to the negative 1 below becomes 5 to the positive 1 on the numerator. So it is negative 6 times 5, which is equal to negative 30. Next one, 6. Negative 5 to the negative 1 over xy square. So the denominator need not have to be touched. It can stay as xy square. Negative need not have to be touched. So it's negative. Then we have xy square in the denominator that stays as is. 5 to the negative 1 can be written as 1 over 5 to the positive 1. 1 over 5 to the positive 1. So it is equal to negative 1 over 5 xy square. Number 7, x cube x to the power 6 times x to the power 4. We have the same base and then the exponents are different. So you can add the exponents, which is 3 plus 6 plus 4, which is x to the power 9 plus 4, which is 13. X to the power 13. Now, x to the power 4 to the power 9, it is power over a power, which is superpower. So we have this rule here, power rule, b to the power m to the power n is b to the power m times n. That's the rule we use here. So x to the power 4 to the power 9 is x to the 4 times 9 multiply. So it will be x to the power 36. Then we have a negative exponent here. So if you have a negative exponent, you can actually flip and then make the exponent positive, right? So I'm going to flip, you are going to flip this and make the exponent positive. Then exponent positive. So it's going to be 8, or we take the reciprocal. By flip I mean take the reciprocal. So 8x square y cube, the denominator becomes a numerator. Then we have minus 3 x to the power 4 y all to the power positive 1. So anything to the power positive 1, you can leave the base as by itself. So it is negative 8 over 3 x square y cube over x to the power 4 y. You can simplify now. X square here, it is x to the power 4, that will become x square below. Then y here, y cube, that will become y square. So it will become ultimately negative 8 over 3 y square on the numerator. Denominator is x square. Here note, here we used x square over x to the power 4 is denominator x square. So to explain that, x square over x to the power 4, either you can use quotient rule or we can write this as x times x. This can be written as x times x times x times x repeated 4 times. So you have 1 on the numerator, denominator is x square. Or in other words, x square over x to the power 4 can be written also as 1 over x to the power 4 minus 2. So it's 1 over x squared. Either way, same way y cube over y, this can be written as y to the power 3 minus 1, so which is y squared. That's how we get that y squared there. Problem number 10. It's something to the cube, something to the square. So if you apply the rule that we have, if you extend this idea of a times b to the power m is a to the power m, b to the power n. And if we have something to the quotient to the power m is numerator to the power m, denominator to the power m. So we are going to use that kind here. It is 2 cube. Raise everything to the power 3 on the numerator. A to the power 7 cube, b to the power negative 4 cube, then divided by 4 square, a cube square, b to the power negative 2 square. So 2 cube, which is 8, 4 square, that is 16, then a to the power 7 times 3, 21, b to the power negative 4 times 3, that is negative 12, then a to the power 6, 2 times 3, then we are going to multiply b, negative 2 times 2, which is negative 4. Then it's always a rule of thumb that we never leave any answer with a negative exponent. So if there is negative exponent, you have to somehow make it positive. So it's 1/2 here if you reduce. Then here, I can take this guy on the numerator and write this as minus 6. Then I can take, I can write this one. There are 2 ways to do. You can make that as positive. And then in the end, you should not have any negative exponent. Make sure you don't have one. 21 minus 6, which is going to be 15. Then we have b to the power negative 8, but we don't leave anything with the negative exponent. So it is 1/2 a to the power 15 on the numerator divided by b to the power positive 8. So you bring the negative exponent, negative 8, bring it down and make it positive exponent. So we have number 12. We are going to do number 12. So 9, negative 9, m to the power 5 t times 3 m to the negative 2t cube divided by 4t to the power 6 negative 3. So we can actually, because of the negative exponent, you may want to flip this or take the reciprocal. So we write this as 4t to the power 6 divided by 3m to the negative 2 t cube whole thing to the power 3. So it will be negative 9 m to the power 5 t. Then raise everything to the power 3. So it is 4 cube t to the power 6 to the power 3 divided by 3 cube. Everything is raised to the power 3, keep in mind. Negative 2 to the power 3, then t cube to the power 3. So now it will be negative 9, so negative 9 m to the power 5 t, then 4 cube, which will be 64, 4 times 4 times 4, that is 64, then t to the power 6 times 3, which is 18, divided by 3 cube, which is 27, 3 times 3 times 3 is 27, then m to the power negative 2 times 3, which is negative 6, t to the power 3 times 3, that will be 9. Alright, so it's going to be now We are going to adjust and simplify this.